Good morning. Good morning. Register number 19 series letter. Why he is absent for so many classes? Present ayyada iroju. Durga Prasad. Anybody please respond? Lateral entry number 19 is not attending for the classes from past 4 periods. Tell me what is the major difference between BPSK and BFSK? What is the major difference between BPSK and BFSK? Binary phase shift keying and binary frequency shift keying. Please respond. Anybody? చెప్పాలమ్మా ఆన్సర్ చెప్పాలి. హలో హలో ప్లీజ్ రెస్పాండ్. 61 members ఉన్నారు. వీడియోస్ ని అన్మ్యూట్ చేయండి. Please unmute your video. Unmute your video. My voice is audible to you. Respond, please respond. E9. Number E9. F2. C2.
Yes, ma'am.
Unmute చేయండి video. Okay. Nobody responded for that question. What is the major difference between BFSK and BPSK? Anybody? Please respond. Hmm? మరి ఎందుకు మీరేమి రెస్పాండ్ అవ్వకపోతే ఆన్లైన్ క్లాసులు ఎలాగా చెప్పడము ఏమా ప్లీజ్ రెస్పాండ్ because of only attendance you are attending or you followed the lesson. Hmm? D4 కావ్యశ్రీ
ఎస్ మ్యామ్.
ఏమా వీడియో అన్మ్యూట్ చేయండి సరే. వెరీ గుడ్. ఎలా ఉన్నారు?
గుడ్ మ్యామ్.
ఇంట్లో వాళ్ళందరూ బాగున్నారా?
ఎస్ మ్యామ్.
ఫాలో అవుతున్నారా క్లాసెస్? వెరీ గుడ్.
ఎస్ మ్యామ్.
వెరీ గుడ్. ఏ ఊరండి మీది? ఏ ఊరు? హలో,
రంగాపురం.
రంగాపురం.
రంగాపురం మేడం.
ఏలూరుకి దగ్గరేనా?
ఎస్ మ్యామ్.
ఓకే, మ్యూట్ చేసేయండి. వెరీ గుడ్, వెరీ గుడ్. నెక్స్ట్ E8 తారక్. E8 తారక్. E8 తారక్. Please respond. Tarak. D9 Venkatesh. D9 Venkatesh. ఎవరైతే ఇప్పుడు రెస్పాండ్ అవ్వలేదో మీరు అక్కడ ఉన్నా సరే ఆప్షన్ పెట్టేస్తా. ఐ పుట్ ఆప్షన్ మార్క్. E8.
ఎస్ మేడం.
E8 ఏనా మీరు?
D9 మేడం.
D9. ఓకే, వీడియో మీది అన్మ్యూట్ చేయండి, చూస్తాను ఎవరైనా. ప్లీజ్ అన్మ్యూట్ యువర్ వీడియో. ఓకే, వెరీ గుడ్. అక్కడ ఎవరండి మీది?
ఏలూరే మేడం.
ఏలూరేనా? వింటున్నారా క్లాసెస్?
ఎస్ మేడం.
ఫాలో అవుతున్నారా?
ఎస్ మేడం.
ఓకే. మీరు రెస్పాండ్ అవ్వకపోతే నాకు అసలు మీరు ఆన్లైన్ లో ఉన్నారా లేదా అనేది నాకు డౌట్ వస్తుంది. ప్లీజ్ రెస్పాండ్. జస్ట్ ఎస్ మేడం అర్థమైందా అంటే రెస్పాండ్ అవ్వండి, అంటే ఎస్ మేడం అని చెప్పారనుకోండి. అంటే వన్ సైడ్ మేము మాట్లాడుతూనే తప్పించి మీ నుండి రెస్పాండ్ రాకపోయేటప్పటికి ఏంటంటే మేము డిమారలైజ్ అయిపోతాం. ఏంటి వీళ్ళేమి వినట్లేదా, అసలు ఉంటున్నారా ఆన్లైన్ లో అనేది మాకు కొంచెం డౌట్ వస్తుంది అనమాట. ఓకేనా?
ఓకే
అంటే తప్పించి వేరే విధంగా ఏం కాదు. ఓకే, షల్ వి స్టార్ట్ లెసన్ టుడే? ఓకే. Now I am sharing my screen. So last class we discussed about that binary phase frequency shift keying. In binary frequency shift keying, that is an frequency of that carrier signal is shifted according to that data signal. That is the main function of that. So the basic difference between binary phase shift keying and binary frequency shift keying. In binary phase shift keying, the phase of the carrier is changed according to that data signal. One is there is no phase difference. 0 is there is a 180 degrees phase difference that can be occurred. Whereas in BFSK, the frequency of the carrier, the one is there, the frequency, the carrier, let us assume the carrier frequency is F0. So that frequency is increased to another value, F0 plus some value. So that is FH, higher frequency. And if the 0 is present, the carrier frequency is decreased from the carrier frequency. F0 minus the same amount. Like that here, the frequency is shifted instead of phase in frequency shift keying. So like in this binary frequency shift keying, the symbol consists of only one bit. That one bit, the bit duration is the T bit duration. The main difference of that BFSK and BPSK is very, very important. That is the bandwidth. The bandwidth of BPSK is 2FB. This is for BPSK. The bandwidth for FSK is 4FB. So 4FB for BFSK. Because here the phase is different but same frequency, either 1 or 0. Same frequency is the same frequency. We'll observe that the spectrum F0 plus F terms are present for both the cases, 1 or 0. Whereas in BFSK, 1 is present, the frequency spectrum is FH plus F. For 0 is present, the frequency is FL plus F. So different. So this occupies 2FB and this occupies 2FB. Total 4FB is the bandwidth for this case. Okay, this is a major difference between BPSK and BFSK. And here we can observe that BFSK receiver block diagram. Here we can receive the BFSK signal that can be given to these filters, filter 1, filter 2. So why here the filters that can be used, this is a band pass filters. The bandwidth is 2FB because each bit occupies the frequencies that bandwidth is 2FB. And here different frequencies, that is FH and this is an FL. FH is equal to F0 plus, that is you all are familiar with here. This is omega H is equal to, so omega naught angular frequency of carrier and omega here we written. This is some small amount of frequency. We can write into instantaneous frequencies instead of writing the angular frequencies. So this is FH is equal to, this is also 2 pi F0 kada. Simply here we can 2 pi get cancelled. Here omega by 2 pi. So that's why here we can write like this. Okay. So total FH occupies 2FB. And if one is there, high frequency that can be passes through this one. And 0 is there, the bit is passes through this one, lower frequency. Filter that can be that allows that signal. Another important one, you all are familiar with FM demodulators. The band pass filter is nothing but a frequency selective network. If the input is frequency shift keying, that means like a frequency changed according to that data signal here. The output of this one is AM plus FM signal. That means frequency variation that can be takes place as well as the amplitude variation also takes place here. AM plus FM is the output of this filter. That's why the signal is passes through envelope detector. The envelope detector detects only the envelope of that signal. So here the output of the envelope detector is envelope, that is an DC voltage. So here we can observe that if that is 1 is there, at the output of the envelope detector, the DC voltage is present, and at that time that envelope detector 2, the output is 0. Only at 1 is there, the envelope detector 1, there is an output voltage is present. So then these two are given to comparator So this is an, let us assume this is an +1, this is an -1. So that is a positive terminal, this is a negative terminal. If this is equal to 0, here the positive voltage is present, output is positive. That indicates that the logic 1 is present. If that is 0 is transmitted, that filter 2 is allows that signal, and the output of envelope detector 2 is an voltage, negative voltage, and the output of this envelope detector 1, positive voltage, is equal to 0. Therefore, the comparator output is negative. That indicates that here the negative, that indicates that that is a 0 logic. +1 indicates that, so logic 1 like this. So like that here, we can detect the data signal. We can detect the data signal. So here the filter, it allows the particular frequency signal. So one is there, high frequency signal that can be allowed. And here that is allow
ఎలా చేయమంటున్నారు మేడం?
okay, okay. I will. ఏరమ్మా ఇంకా okay. Then here, so here the filter allows the corresponding frequency signal and that acts as a frequency selective network. You all are familiar with that one, operation of that frequency selective network when the input is an FM signal. If that is an input is an FM signal, the output of this filter, band pass filter, is like this. Please recollect that one. If that is, the amplitude is the same signal obtained at the output of that filter with the same frequency, but amplitude variation that can be takes place. The frequency is less, the amplitude is low. The frequency is maximum, here the amplitude is maximum. Okay, so here we can compare to this one. Here the frequency is less, that means time period is more. The amplitude of that signal is like the same frequency. Frequencies does not change, only amplitude of the signal. The frequencies increases, the amplitude of the signal also increased. The frequency is decreased, the amplitude also decreased. The amplitude also decreased. Like this. Here we can observe that here the frequency is high, the amplitude is high. Here the amplitude frequency is little bit decreased from this one. That's why the amplitude is reduced from this one. Here the frequency is low compared to this one also. That's why the amplitude is drastically decreased. So that means here, according to this frequency variations, the amplitude variation also present at the output of the filter. That's why that is given to this envelope detector. The envelope detector detects only this peak or envelope of the signal. మనకు అవుట్పుట్ ఆఫ్ దట్ ఎన్వలప్ డిటెక్టర్ ఎలా వస్తుంది దట్ ఈస్ ద DC voltage లా వస్తుంది. అందుకని ఏంటంటే, సో హియర్ దట్ ఈస్ ద నెగటివ్ bit is there, that is when 0 is there, negative. At that time, positive is equal to 0. That inputs are given to comparator, then the output is then positive. Negative. Like that, here you can apply. Okay, ఇక్కడ positive representation, negative representation. ఇక్కడ కనుక మనకి వోల్టేజ్ ఉంటే కనుక నెగిటివ్ టెర్మినల్ ఇస్తాం కాబట్టి అవుట్పుట్ నెగిటివ్ వోల్టేజ్ వస్తే జీరో ఇండికేషన్. ఇక్కడ మనకి వోల్టేజ్ వచ్చింది, పాజిటివ్ టెర్మినల్ యాక్టివేట్ అవుతుంది, హై ఉంటుంది. నెగిటివ్ టెర్మినల్ దగ్గర జీరో ఉంటుంది కాబట్టి అవుట్పుట్ పాజిటివ్ అంటే మనకి లాజిక్ 1 అనేది తెలుస్తుంది. సో దిస్ ఈస్ ద ఆపరేషన్ ఆఫ్ BFSK receiver. Then another one is important one is geometrical representation of BFSK signal. Please, this is also very important because in digital modulation techniques, here you can compare the two factors. One is the bandwidth, another one is the distance between the two symbols. Already we are discussed that bandwidth. So in BPSK, the bandwidth is low and compared with the BFSK. Okay, but what is the distance between the two symbols? And then we can compare the distance between two symbols in BFSK with the BPSK. According to that one, which modulation technique is better and in which one the bit errors are reduced or decreased or minimized, here we can estimate that one. So another important one is a geometrical representation or constellation diagram of this signal, BFSK signal. Okay, so here we can discuss here. Please note down geometrical representation of BFSK, binary frequency shift keying. In binary frequency shift keying, first how to write the equation. So the equation is root of PS TB, because the TB is the bit duration. In BFSK, each symbol is consists of only one bit. That's why TB represented. Root of 2 by TB, cos of 2 pi. Here, in a general case, here we can retain that is an omega h into t equation. Similar way, plus root of PS TB, root of 2 by TB, cos of omega LT and RAS. In the place of omega h, so 2 pi FH is written. Similar way here also, in the place of omega L, 2 pi FLT and RAS. So then here, we can write this equation in terms of orthonormal coordinates. We have to draw the constellation diagram, or here we can represent that signal is in graphically. First have to write that equation in orthonormal coordinates. Orthonormal coordinates means, so x-axis and y-axis both are in perpendicular. That is orthonormality. Here we can write that one. So here we can cos of 2 pi ht and cos of 2 pi FLT. In BFSK, the two terms are present, but this is a cos 2 pi ht and another one is a sin 2 pi FLT. Or here in a BPSK, that equation is cos of some omega naught t, whereas in other term is a sine of omega naught t. Directly in that equation, they are orthonormal, that is in perpendicular. But in this case, both the terms in this equation are cos. Both are cos. Ikkada cos undi, ikkada kuda manaki cos undi. So if that is cos, how they are normal to each other, two terms. Why here we can indicate u1 of t, u2 of t. మనం ఎందుకు రాయాలి? ఆ రెండు మనం పర్పెండిక్యులర్ గాని ఎందుకు చూపించాలి? Here you can observe that FH is equal to MFB and FL is equal to NFB. If here we can change these parameters M and here N. So cos of omega naught plus something. So cos ki ni sin ki ఎంత యాంగిల్ డిఫరెన్స్ ఉంటే సైన్ అవుతుంది. So cos of omega naught t, cos of omega naught plus 90 degrees t. Am I correct? Are you understand this one? Please respond. Emma?
Yes, ma'am.
అవును
Yes,
కదా,
ma'am.
కాస్ ఒమేగా నాట్ టీ అంటే ఓకే, కాస్ 90 ప్లస్ ఒమేగా నాట్ టీ పెడితే ఏమవుతుంది, సైన్ అవుతుంది కదా, 90 డిగ్రీస్ వేరియేషన్, 90 డిగ్రీసే కదా డిఫరెన్స్. అంటే ఏంటి ఇక్కడ ఎం మనం ఏదైనా సెలెక్ట్ చేసుకున్నాం అనుకోండి, ఇక్కడ ఎన్ అనేది కరస్పాండెంట్ గా సెలెక్ట్ చేసుకుంటే, ఇప్పుడు కాస్ అనేది సేమ్ ఉన్నా, సో ఇక్కడికి వచ్చేటప్పటికి ఈ కాస్ వచ్చేటప్పటికి ఈ ఎన్ వాల్యూ సబ్స్టిట్యూట్ చేస్తే మనకి ఏం రావాలి, సైన్ రావాలన్నమాట. అలాగా హియర్ యూ కెన్ చూస్ ద వాల్యూస్ m and n values, then that equation is an orthonormal. That's why here we can replace this equation by properly selecting that m and n values. Here we rewrite that equation, root of EB is nothing but PS TB and U1 of t. So this is an U1 of t. And again plus root of EB, this is nothing but a U2 of TB. Because here we can select the n and n values. So according to the both the terms that are in perpendicular orthonormality. Then this is the resultant equation. Then here we can draw the constellation diagram or geometrical representation of that signal. So in this one, this is U1 of t and U2 of t, both are perpendicular with amplitudes root of AB, and this is the root of AB. Then here you can find out the resultant of these two bits is equal to the resultant of this one is nothing but the root of a square plus b square. A is root of AB whole square plus b is nothing but again root of EB whole square. That is equal to root of 2 into EB. Root of 2 into EB is the distance between the two symbols in BFSK. Here, the distance between the two symbols in BFSK, the distance between the two symbols is equal to root of 2 into EB. Okay. So whereas in BPSK, the distance between the two symbols is equal to 2 into root of EB. Am I correct? Is correct any equation? Antena miru? Emma, BPSK lo 2 into root of EB ana? Distance between two symbols?
Yes, ma'am.
Very good. A9?
Yes,
very
ma'am.
good. Very good. Okay. Or you understand how we can get distance between two bits in BFSK? ఎలా ఆర్థోనార్మాలిటీ అవుతుంది, రెండు కాస్ట్ టర్మ్స్ ఉన్నా సరే ఈ ఈక్వేషన్ లో మనకి ఒక టర్మ్ ఇస్ పర్పెండిక్యులర్ టు అదర్ టర్మ్ ఎందుకు అవుతుంది, దాన్ని ఎందుకు ఆర్థోనార్మల్ గా ఎలా రాస్తున్నాము అనేది అర్థమైందా అమ్మా?
Yes, ma'am.
దెన్ సో బ్యాండ్ విడ్త్ కంపేర్ చేస్తారు, డిస్టెన్స్ కంపేర్ చేస్తారు. అకార్డింగ్ టు దీస్ కంపారిజన్స్ విచ్ వన్ ఇస్ బెటర్ వన్, BPSK-నా BFSK-నా?
BPS కి బెటర్ మ్యామ్.
BPSK బెటర్. ఏమో మిగతా వాళ్ళకి కూడా అర్థమవుతుందా? కంపారిజన్స్ ఎక్కడికక్కడే రాసేసుకోండి, బికాస్ మీరు ఊరికే థియరీ రాసే కంటే ఈక్వేషన్ రాసి డెఫినేషన్ రాసి ఈక్వేషన్స్ రాసి బ్యాండ్ విడ్త్ ఈ సిస్టంలో అయితే ఇలా ఉంటుంది, ఈ సిస్టంలో అయితే ఇలా ఉంటుంది, డిస్టెన్స్ ఈ సిస్టంలో ఇలా ఉంది, డిస్టెన్స్ ఈ సిస్టంలో ఇంత ఉంది, సో వాల్యూస్ని సబ్స్టిట్యూట్ చేసుకుని, సో డిస్టెన్స్ ఏ సిస్టంలో ఎక్కువగా ఉంటే దట్ వన్ ఈజ్ అన్ బెటర్ వన్. బికాస్ 2 సింబల్స్ దూరంగా ఉన్నాయి అనుకోండి, డిస్టెన్స్ ఎక్కువగా ఉందనుకోండి, ఎర్రర్స్, ప్రాబబిలిటీ ఆఫ్ ఎర్రర్స్ అకరెన్స్ అనేది తగ్గిపోతుంది. అదే బ్యాండ్ విడ్త్ కనుక తక్కువగా ఉన్న సిస్టమ్ బెటర్ సిస్టమ్. బ్యాండ్ విడ్త్ ఎక్కువగా ఉంటే మనకి ఏమవుతుందంటే కాస్ట్ అనేది పెరిగిపోతూ ఉంటుంది అనమాట. బ్యాండ్ విడ్త్ ఇంక్రీజ్ అయ్యకుండా మోర్ నాయిస్ ఇస్ అడ్మిట్స్ ఇన్ టు ద సిస్టమ్, ఎక్కువ నాయిస్ అనేది వచ్చేస్తూ ఉంటుంది. అందుకని సో హియర్ బ్యాండ్ విడ్త్ తక్కువగా ఉండాలి, డిస్టెన్స్ ఎక్కువగా ఉండాలి. దట్ సిస్టమ్ ఈజ్ అన్ బెస్ట్ సిస్టమ్ అవుతుంది. ఈ కంపారిజన్స్ ఇప్పుడు we have to compare all those systems according to that parameters. Okay, then next one is an M array FSK. So M array already we are discussed in M array PSK. Similar way here also M array FSK. Okay, in M array FSK, similar way here also. M indicates that number of levels. So M is equal to 2 to the power of n. So if the n is equal to 1, so symbol consists of 1 bit. N is equal to 2, symbol consists of 2 bits. 2 to the power of 2, combination. The 4 symbols are present. The 4 symbols with different frequencies. 0, 0, 1 frequency. 0, 1, another frequency. 0, 2, another frequency. 0, 3, sorry. 0, 0, 0, 1, 1, 0, 1, 1. The 4 symbols has a different frequencies that can be transmitted by transmitting antenna. The number of symbols that can be increased, the frequency that can be divided. So here 2 to the power of 3. So 2 to the power of 3 is 8 symbols. Each symbol consists of 3 bits. So each symbol has its own frequency. F0 plus something. F0 plus F1, F0 plus F2, F0 plus F3, F0 plus F4, like that. If the 256 symbols are there, 2 to the power of 8, 256 symbols are there. Each symbol has its own frequency. Like that. Like that, here we can transmit the signal. So that means each symbol occupies its own frequency, not overlapped with them another frequencies. Okay, so that is the about M array FSK. In M array FSK, here we can observe that if n is equal to, generalize the bandwidth of this one here. Here in this case, so in BFSK the bandwidth is equal to 4 FB. So here we can indicate that the 2 are the multiplication factor, 2 is the levels, here 2 is the level, 2 is an factor, and here generalized that is an FS. FS is consists of, so in a BFSK, FS is equal to 1 by TB. Here we can in 1 by TB. So that indicates that this is equal to FB. So like that here, 2 to the power of M, sorry, here n plus 1. Here you can generalize the bandwidth for this one. 2 to the power of n plus 1 into here Fs. So n is number of bits plus 1. It could according to. So 2 factor 2 to the power of n. Again extra 2 is there. N plus 1 into Fs. So like that here you can substitute that one. Again you will get 4 FB. So for m number of levels are there, where m is equal to 2 to the power of n, the bandwidth is equal to, here we can, 2 is the multiplication factor. So let us assume here in this case, n is equal to, this is an example for n is equal to 2. 2 into m into fs. So for n is equal to 2, number of levels are 4. That's why. Into fs. What is fs? Fs is equal to 1 by, fs consists of 2 bits. Duration is 2 dB. 1 by 2 dB. That is equal to fb by 2. Then we can substitute, this is equal to f into fb by 2. Otherwise here we can generalize that equation. The bandwidth is equal to 2 to the power of n plus 1 into fb by n. So here we can replace fs is equal to, where fs is equal to symbol duration is equal to fb by n. Like otherwise here fs is equal to, for n bits are present, 1 by n into tb. So therefore fs is equal to fb by n. So then here directly we can substitute the bandwidth of that system m array fsk equal to 2 to the power of n plus 1 into fb by n. Okay. So this is the bandwidth for m array fsk. For m array psk, the bandwidth is equal to, the m array psk, the bandwidth is equal to 2 into fb by n. Okay. So here this is, we can compare. This is a bandwidth in m array psk. This is a bandwidth in m array fsk. The bandwidth is large in fsk, m array fsk, when compared with m array psk. Okay. So this is the one parameter is compared in m array psk and m array fsk. Okay. Now compare, that is the distance between the two symbols in m array psk and m array fsk. So what is the distance between two symbols in m array fsk? Anybody? Chappal naku. What is the distance between the two symbols in m array fsk? According to equation, please tell me. So here we can write an equation for m array fsk. Equation for m array fsk. So here we can observe that this equation, in this equation, root of PSTB, only one bit is there, bit duration. Instead of writing this TB, here we can write TS. Root of PSTS into root of 2 by, instead of writing this TB, here we can include TS. Cos of 2 pi FHT plus root of PS TS, root of 2 by TS, cos of 2 pi FLT. Then here same FH is equal to M into FB, or FL is equal to N into, so instead of FB is an that one here, FS, here we can consider this is an FS. Here also, here we can consider that FS. Again here this is U1 of T, this is an U2 of T. Then here we can find out the distance between these two symbols. Anybody? Chappandamma. A9?
Yes, ma'am.
What is the distance between two symbols? Instead of root of EB, ikkada em teeskovali, root of ES teeskovali. What is the distance between two symbols?
2 into root of EB into sin square pi by 2n 2 power n plus 1, ma'am.
BFSK can. BFSK key distance between two symbols allows. First you have to write equation. Equation ఎలా రాస్తారు? Equation for M array FSK. FSK, M array FSK. Equation for M array FSK is root of PS TB plus ఏం రాయాలి? TS. TB అంటే only 1 bit duration. TS అంటే in this case M array కదా. TS is equal to N into TB. Am I correct? So again 2 by TS cos 2 pi FHT plus root of TS into root of 2 by TS cos 2 pi FLT. So again here we can select FH is equal to M into FB, FL equal to N into FB. We can select. Here we can indicate that M and N at particular point both are in perpendicular. Then we can draw this phasor diagram or constellation diagram for this one. So this is an U1 of T. This is an overall. This is an U2 of T. Then we can draw the diagram. This is the U1 of T with the amplitude. Enta root of TS is the root of ES. And for this one, this is the U2 of T. This is an again root of ES. The amplitude of this one is the root of ES. ఇక్కడ వరకు అనుకోండి. Then here we can draw the resultant of this one. Here the resultant is enta root of 2 into ES. Here you can write in terms of EB 2 into TS. TS is nothing but N into TB. Therefore, this is equal to root of 2N EB is the distance between two symbols in M array FSK. Please note down. The distance between the two symbols in M array FSK is root of 2 into N into AB. This is an M array, sorry. M FSK, array FSK. Whereas in M array PSK, the distance is how much? ఇందాక మీరు చెప్పారు కదా ఎంత అంటే నాకు చెప్పండి. How much?
Two root n into EB sin square pi by 2 power n.
2 into root of NEB
Sine square of 5 by 2 power n.
sine square of 5 by 2 to the power of n. So, in which case the distance is greater than, or distance between one symbol to another symbol is maximum in which system? According to this one here, we can find out. చెప్పగలరా ఏ సిస్టమ్ లో మనకి డిస్టెన్స్ ఉంటుంది? ఒకసారి n is equal to ఎంత తీసుకుంటారు? n is equal to 4 కి క్యాలిక్యులేట్ చేయడము in terms of ABS లో వస్తుంది. n is equal to 4. What this one? Root of 2 into 4 into EB. Root of 8 EB వస్తుంది. For this case ఎంత వస్తుంది? చెప్పాలి, ప్లీజ్ టెల్ మీ. n is equal to 4. 4 EB sin square 5 by 2 to the power of n. 2 to the power of ఇక్కడ 4 ఎంత? sin square 5 by 2 to the power of 4 ఎంత? చెప్పండి ప్లీజ్. Please calculate. Then we can compare which one is the best system. ఏ సిస్టమ్ లో బిట్ ఎర్రర్ రేటు తక్కువగా ఉంటుంది? ఎర్రర్ రేట్ తక్కువగా ఉంటుంది. Okay, A9. ఏమో క్యాల్కులేట్ చేశారా? A9 Manidip B9. Manidip, where are you? Manidip. Manidip, where are you? Please respond. A9. Emma, A9 calculate చేసారా? మిగతా వాళ్ళు A4. నితేష్ ఎవరు రెస్పాండ్ అవ్వట్లేదు ఏంటమ్మా? మీరు చేస్తే మీకు అలవాటు అవుతుంది, నాకు వెంటనే మీకు కూడా ఐడియా వస్తుంది.
M array FSK కి గ్రేటర్ మేడం.
M array FSK కే గ్రేటర్. అంటే ఇక్కడ అబ్జర్వ్ చేయవలసింది ఏంటంటే BFSK BPSK కనుక అబ్జర్వ్ చేస్తే BPSK బెటర్. ద నెంబర్ ఆఫ్ లెవెల్స్ ఇంక్రీజ్ అయ్యే కొందన M array FSK కి డిస్టెన్స్ ఎక్కువగా ఉంటుంది కాబట్టి ఎర్రర్ రేటు తక్కువగా ఉంటుంది. సో మనకి ఎర్రర్ రేట్ రాకూడదు అంటే BFSK M array FSK కి వెళ్ళాలి. ఓకే, అదే మనకి బ్యాండ్ విడ్త్ తక్కువగా ఉండాలి అంటే PPSK కి వెళ్ళాలి. ఓకేనా? సో we can conclude at this time. Emma, are you understand the comparisons between BPSK, BFSK And MRA PSK and MRA FSK. Okay. Shall we stop here? Thank you. Respond only. Thank you.
Thank you, ma'am.
Thank you, Amma. Oh, very good. Very good. Assignment questions ఇచ్చేసారా అందరు సార్స్?
లేదు మ్యామ్ ఇంకా.
ఇంకా ఇవ్వలేదా? సరే. నెక్స్ట్ క్లాస్ ఆన్వర్డ్స్ I will start next unit, third chapter tomorrow. Then I will give assignment questions. Okay? Now, thank you. Now we will stop here.